Hello class, this is the instruction video for the last lab that we have in the semester, which is a climate change lab. So although your lab manual does have a climate change lab, which is also the last one on that lab manual, I'm not a huge fan of it, and so what I'm going to do is give you the lab that I usually give my students for the natural disasters class that I have, which is a little bit, I think, more encompassing as to what climate change topics we have. So we're going to do that. So when you go to your course, which again is going to be under lab for this particular assignment, you're going to go under topic modules, Spring 20. Again, yours is going to look a little bit different, but basically the same idea. And then you're going to go to the climate change chapter 20 tab. So and then you're going to see the instructions for completing this climate change lab. So you have the typical instructions, so watch these videos that I am recording right now, and then you're going to have one document really, which you can access either here or through this link. So if you click on it, that's going to be the actual kind of handout. So you can print it if you'd like, or you can just do it online as you go. It's your call. So as you're going to see, it's not the lab number doesn't correspond with the lab number that we have right now. And as you can see, it's for Geology 104, not for 101. Again, we're going to use it regardless of that, because I think it is better than the one that you have in your lab manual, at least for an online delivery as well, for me to also be able to grade you accordingly. So we're going to use this. So this lab has 3 parts. So in here, I have additional instructions. To be honest, these videos are somewhat useful, but you don't really need to listen to this particular video. If you want to just go ahead and get started on the lab, that is completely fine. The instructions that are within these document, along with these additional instructions that you have right here, that should be enough to complete the lab if you'd like. If you want to go through it with me by listening to this video, you definitely can. And as always, you have me during your normal class and lab hours for me to be able to help you through Blackboard Collaborate Ultra. Okay? Alright, so once you have gone through the document, again, which you can access here or here, and completed it, go ahead and submit your answers through the lab quiz, which has been pretty standard for now. So you're going to go down here and take the quiz. In this particular case, you have 2 tries, because that's what I usually give my 104 students, so I wanted to treat you similarly. You're both on the similar level, and it's a similar difficulty for both courses, so I figured that that would be the only fair thing. So you have 2 tries. Both of them are timed 30 minutes. I think all of the answers are multiple choice or multiple answer, so you don't even have to input short answer ones. So you should be pretty good on time and on delivery. Okay, so we're going to go through the lab shortly this time. I don't think it will take too long, along with the answers on the quiz, or the possible answers on the quiz. Okay. So, okay. So, as I said, there are 3 parts to this lab. All of the lab was created by the Department of Geography from the University of Idaho. But it has been greatly modified both by Melissa Schlegel, which was one of the previous geology instructors at CWI, and by me as well. So here they go through a little bit of a summary on what is climate, why do you need it, how is it possible that we have proxy records or proxy data, which we have seen in lecture, right? Whatnot. So here they also go through I go through the goals for this lab. And the outcomes, the equipment that you need. So for this lab, you need a calculator, a ruler that has centimeters and millimeters specifically, okay? And then you need, obviously, computer with internet access. And you could need a printer. It's not necessary, but for some people, it helps a lot. So if you'd like to print this out, you need a printer. Okay. So the first part is called Calculating Climate. So I'm going to go ahead and read it with you. So climate is determined by a variety of global factors, but it is observed through the day-to-day collection of weather information and subsequent analysis of that information. If you watch the weather on TV or look for weather forecasts on the internet and the forecast says it is going to be 5 degrees hotter than normal or drier than normal for the month, the forecast is using a very careful calculated version of normal. This version of normal depends on how many years of data are being analyzed and where the weather recording stations are located that contribute to that dataset. So for example, while there is a weather recording station on campus, it can be at CWI, in this case they're talking about the Moscow campus, the nearest one used by the National Weather Service, which provides the official reading for the area, is at the Pullman Moscow Regional Airport, which is 7 miles away from the Moscow campus. So actually the one that we have closest to us that is recording all the time and has data for, I think, over 80 years is at the Boise Airport. Airports tend to be pretty common. So the map on the next page, this one right here, shows two local weather, shows two local weather recording station locations. One is the Pullman Moscow Airport, which is located here as you can see in this map, and the other one is the Lewiston Airport, which is down below here. Most official U.S. weather recording stations are at airports or remote locations in the mountains, not in populated suburbs and rural areas. So, as you saw in the climate change lecture of this week, there can be many things that skew the temperature recording. So, for example, if they're in greatly populated areas or suburbs, you can get a heat island effect kind of thing. And so the temperatures would be greater than the actual average for that region. So they tend to be in relatively isolated areas so that it can be more of a combined true temperature. Okay, so instead, weather forecasters use the closest stations and calculate the predicted conditions between them. You might observe consistently different weather at your house than what the National Weather Service or your local weatherman reports for your area. And that is completely true. So that is why if you are searching on your weather app, typically they ask you, where do you want the location to be your location? Can it be the closest one to your house? Or do you want it to be, for example, at the airport? Or do you want it to be several miles away? It doesn't matter. But you'll see that those can be very different temperatures depending on where it's located. Okay. So again, if you're not familiar as to where Lewiston and Pullman are, this is northern Idaho. Lewiston used to be the state's capital a long time ago, and this is Moscow right here where the University of Idaho is. Pullman is in Washington. And so Pullman and Moscow kind of share an airport, which is located mostly in Pullman. It's a little bit closer to Moscow, but still in Washington. And so these two locations, they're about 40 minutes away from one another. Boise here is about 5 hours from Lewiston to the south, almost completely south. Okay? A little bit to the east of it. Okay, so that's for reference. Okay, so first, also I should mention that when you're going through the lab, questions that are in blue, you have to answer for being able to answer the following questions, but they will not be questions within your quiz online, okay? So the first question that you have in your quiz online is actually 1C, okay? So 1A says calculate the average high temperatures for June 2008 for each station. And again, I should read this. So on the following page, there is a table. Ta-da! On the left part of the table is a record of the daily high temperatures recorded for a single month. What they mean by daily high temperatures is the average high temperatures that were recorded every day, and in this case, every month as well. So June 2008 for both Pullman Airport and Lewiston Airport weather stations. On the right part of the table is a record of the average high temperatures for each June from 1990 to 2019. So that's 30 years of data for each of the stations, but the 2008 June average is missing. So if you look at the table, these are the days of June 2008, and it's giving you the temperatures in Fahrenheit for Pullman and Lewiston Airport, and so all of the temperatures are recorded for those 30 days of June, but they haven't given you the average. And the right side of the table, they give you the high average temperatures for the June month of each year, except the 2008 one. Okay? So, once you know the average June 2008 temperatures for each of the stations, you can determine the normal June temperature for each station by calculating the average of 30 years of monthly averages. So, in order to do that, you go through these steps. The first thing you need to do is calculate the average high temperatures for June 2008 for each of the stations. So the way you do that is, hopefully you've done averages before, is you're going to add up these temperatures for the Pullman station, and then you're going to divide them by however many records there are. So in this case, there are 30 records, so you're going to add all of those temperatures, divide them by 30, and that's going to be the temperature, the average temperature for June of 2008 at the Pullman station. For the Lewiston station, you do the same thing. You will add all of the temperatures recorded at Lewiston and then divide them by 30, which is the number of days. And that's going to be your average temperature for the June 2008 Lewiston temperatures. Okay, so once you have that, you're going to fill in the missing June 2008 average temperature in the 30-day or 30-year table on the right. So that average that you got down here, you're also going to input it over here. Okay? So if I got 60 average here, I'll put a 60 here. If I got an 80 here, I'll put an 80 here. Whatever you get. Lastly, you'll calculate the average high temperature for June, all of June months, over the 30 years from 1990 to 2019 for each station. So you do that similarly to how you did the column on the left. So you will add up all these temperatures of the Pullman station. Now that you have this one, it'll be easy. And you'll divide all of these by 30, which is the number of years that you have data for. And you'll get an average temperature for all of June months for the 30 years. You'll do the same thing for the Lewiston one, and you'll get a possible answer. So when you go to your quiz, the question will be, what is the calculated average high temperature in degrees Fahrenheit for June over 30 years from 1990 to 2019 for each station? And then you have a set of answers for Pullman and Lewiston airports. Okay. So once you get that done, you have a set of answers after that, or a set of questions. So for Pullman, was June 2008 warmer or cooler than normal? So here what you do is you check the difference between the average June temperatures and the temperatures that you got for June of 2008 for Pullman. And you do the same thing for the Lewiston one. So you'll check the average that you get for June temperatures and the average June 2008 temperature. And you'll tell me what the difference is. In your quiz online, there are certain possible answers, warmer or cooler, and different degrees that were different for both of the stations. Okay, number 4. From a climate perspective, how much warmer is Lewiston than Pullman in June? So they're already telling you that Lewiston is warmer, but they're asking you how much warmer is it in all of June months. So here you'll take the average June temperatures and you'll subtract the temperatures from Pullman from the temperatures from Lewiston, and you'll see how many degrees warmer Lewiston is than Pullman. So what do you think, number 5, what do you think this normal temperature difference between the two cities exists? And so you might have to do a little bit of research, or at least thinking about why it could be different based on the locations of those two cities. Or you could give me different ideas. Once you go into the quiz, there are specific things, there are specific options, and so you'll be able to choose based on that. Okay. Number 6. So the Pullman Airport station is at 2,545 feet in elevation, while the Lewiston station is at only 1,500 basically feet in elevation. Kendrick, Idaho is an equal distance from each station and has an elevation of 1,400 feet. Do you think that Kendrick climatically is more like Pullman or more like Lewiston, and why? So that's your call based on what you have learned thus far, based on lecture and maybe your own experience. So I just want to show you where Kendrick is. Kendrick is right here. So it is pretty much equal distance. It is in Idaho, but that gives you at least a reference geographically.